Hello guys, so today we're doing question 236 of LeetCode, lowest common ancestor of a binary tree, which is very similar to question 235, and we can actually use the same solution I have given for the previous question. But this question is, given a binary tree, find the lowest common ancestor of two given nodes in the tree. According to the definition of LC on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. So example 1, the tree has a root node of 3, has children of 5 and 1, 5 has children of 6 and 2, 2 has children of 7 and 4, 1 has children of 0 and 8. And P is 5, Q is 1, the output is 3. So because as you can see, the lowest common ancestor is 3, or 5 and 1, the closest ancestor here. And example 2, the tree is the same, input is 5 and 4. The output is 5, lowest common ancestor of nodes 5 and 4 is 5, since that node can be a descendant of itself according to the LCA definition. So the way we do this is again by using post-order traversal. So we'll start going down the left tree, and if we find the node, we return it, and we continue until we find both nodes. If both nodes are found, we return the node closest to both nodes. So let me show you an example here. Okay, so the main difference between a binary search tree and a binary tree is that a binary search tree, every node on the left of the root of the node, so everything on the left would have to be smaller than the node, but everything on the right would have to be bigger. That's with a binary search tree. But with a binary tree, it doesn't matter, they're all in any number, any order. So let's say they have a tree here. Let's say we have P and Q, which P, let's say do 5 and 4. P is 5, Q is equal to 4. So we start at the root value and we check, is that node equal to P or Q? It's not, so we go to the left and we're at 5. Is that node equal to P or Q? Yes, it's equal to P. So here, let's say this is P. Then we go to the left again until we find Q, or until we find both. 6, is that equal to P or Q? No. So we go down again, this is null, we go back up, this is null, go back up. Now we're at 5, we go down to 2. Now is 2 equal to P or Q? No. So we continue. We're now down at 7. 7 equal to P or Q? No. We go down, it's null, we go back up. Null, we go back up to 2. Now we're at 4. Is 4 equal to P or Q? Yes. 4 is equal to Q. So we go all the way back up because now we found both. 5, or first we check here. Null, null, go back up to 2. We'll go back up to here. So at 4 we return Q, and at 5 return P. So now P has found both P and Q. So we return 5 as the node. So 5 is the lowest common ancestor. Let me show you how this is done in code. So similar to the other solution, or it's exactly the same to be honest. So create a base case of if no root, we return null. So we don't create an infinite loop. Then if we have found, so if root is equal to P or root is equal to Q, we have found the node, so we return that node, so return the root. Then we have to get the left value, so let left is equal to recursively check lowest common ancestor for root dot left to check the left subtree P and Q. Then we do the same for the right. Let's just paste that. So right is equal to lowest common ancestor of root dot right. Now, if we have found both, so if left and right, then we return that root or that node. Else we return either left or right, whichever we have found. And let's see if that passes. Yep, let's submit. Okay, as you can see, this is the average runtime complexity, which is a time complexity of ON. As a worst case looping through the whole tree. And it's a space complexity of O1. Thanks for watching.